Hey Seed Ruly Chemistry students, how you doing? It's Mr. E. Hey, we're getting near the end of our unit on gas pressures, and I thought I'd show you a demo here, kind of interesting with some dry ice. And so I just want to remind you that dry ice, which is carbon dioxide, and it's frozen carbon dioxide, and at 110 degrees below 0 Fahrenheit, it begins to melt. But it skips the melting stage and goes right to a gas. And as you might recall from, I think, our first or second lesson in this distance learning, that's called sublimation. So sublimation is going directly from a solid to a gas. What makes dry ice dry is that it doesn't go through a liquid stage. It needs extra pressure to do that. And so it just immediately changes to a gas. Okay, so we're going to play around with it a little bit right here. And so there's my information on that. Turns from solid to a gas. Here's your science with your numbers, Celsius minus 79. So it melts, but it doesn't really melt. It goes straight to a gas. Okay, so I'm going to get a piece right here. I'm running out because the stuff is always sublimating when you buy it, but I'm doing okay. So I got a chunk of it right here. Okay, so this stuff is so cold, it's hot, right? It stings. Okay, so I'm going to break this up into some chunks right here, okay? And one thing you can see is that when you put it in water, and they use it a lot in concerts and things like that for their smoke machines, and really all it's doing is it's the vapor coming off right there, and it's turning right away into a gas in the liquid right there. It just helps it along. Something else that happens with it, you can notice sometimes, is you can just zip this stuff around. And the reason is that sometimes it'll form a little layer of gas underneath it right there. And you can hear it sizzling on the table right there. So if you pick it up, you got to be careful, because there it is going away. Dry ice, nothing melting right there. Okay, so what we're going to do now is a little something that I don't encourage you to do this at home. This is pretty dangerous. In fact, you have to be 18 to buy dry ice. I bought this at Fred Meyer. And so what we're going to do is that a couple ways to change pressure we learned about were change the volume, change the temperature, and add molecules of gas. We haven't learned that part, but I'm going to show you right here. When I take this dry ice right here and I put it in this bottle right here, and it starts to change from a solid into a gas, it's releasing molecules into the container. And so I don't know if that's enough or not, we'll see. Okay, I'm going to build that up. Now be careful, I have trouble with these Kirkland bottles because the lid won't stay on. Okay, so we're adding. Okay, so now we need some earplug. Luckily I have lots of things to play with here. You would hear it growing up right here. It's in there, but I think I left it. Okay, so what I'm doing here is I'm putting some dry ice into this bottle, and I'm going to seal it. And what it's going to do is it's turning into gas, and it's adding gas molecules to the container. So it's adding gas molecules to the container, and so what am I doing? I'm increasing the volume. And as I increase the volume, what am I doing to the pressure? Well, I'm increasing the pressure. That's Boyle's law. That's the one we learned. We did not learn about the moles here, which is what they're called, the particles of gas, but they also contribute to it. Okay, so there you go. Some demos dealing with gas law changes. Oh, I'm broken 2 bottles. How did we do that? We just put dry ice into the bottles and sealed them. Well, dry ice is a good example of sublimation. which is changing phase, going from a solid to a gas, and dry ice starts to do that at 110 degrees below 0 Fahrenheit. So it's really hard to store because it's always changing back into directly to a gas, not leaving any liquid behind. What we did with the bottles is I changed the pressure by putting gas molecules in, because the CO2 sublimates, releases molecules into the bottle. More molecules, the volume wants to go up, and more pressure on the sides of the container, and sure enough, kabooey, kablooey, you get that to go. Also, another point of that is it's windy out here, and I couldn't get the papers to stay on the table till I put a little water underneath them, and then through the cohesive and adhesive properties of water, they are sticking right there, even though the wind is blowing things off the table. Okay, Chem students, have a good one. See you later.